For today's video, we're going to look at special cases that occur when you're solving quadratic equations. So right now we know how to solve quadratics by graphing and by taking square roots. So we're going to look at some special occurrences that happen when you're solving with quadratics. So for today, we'll title this Special Cases for Quadratics. So then make sure to put today's date up in the top left or in the top right, whatever makes more sense for you. So really quickly, let's take a look at solving a quadratic equation by taking square roots. So when I gave you an equation like this problem earlier in a previous video, we were able to solve this by undoing. So to get the x squared by itself, I have to get rid of the 3 and I have to move the 10 out of here. So we normally start off by taking care of the addition and subtraction before we can divide away the 3. So the first thing we have to do is subtract 10 on both sides. So I've got 3x squared remaining equals 27. And now to solve this equation, I just divide both sides by 3 and get x squared equals 9. To undo the square, we square root both sides. So remember, when you square root x squared, you just get x, but there's going to be two solutions for it. You get x equals 3 or x equals negative 3, because negative 3 times negative 3 is also 9. So this was like the normal example that we've seen that we did before and that you guys showed me that you were able to do. Today we're going to look at some problems that occur with different types of quadratic equations. So we'll label this one number 1. This was the same old, nothing special about this example. Let's take a look at a problem like this. So it's going to be the same problem, same type of problem, 2x squared plus 10 equals negative 18. So I'm going to solve this the same way that I solved the one above. I'm going to undo the adding or subtracting. So here I'll subtract 10 on both sides. So I get 2x squared equals negative 28. And I'm going to divide both sides by 2. And get negative 14. All right, so here's the problem that we're going to face. I have to square root both sides. So I'm going to square root. And I'm going to pull up my calculator so we can see that. So here's my virtual TI. So we're going to square root. So remember, to square root, we hit second x squared, and then you type in the number, negative 14. All right, so I'm going to do the square root of negative 14. And look at what my calculator tells me. It tells me non-real answer, not possible. So it's not a mistake. Generally, when you see problems like this, you're not able to square root negative numbers because there isn't a number that you can multiply by itself to get a negative. Because remember, a negative times a negative is a positive, and a positive times a positive is a positive. So to find a number that multiplies by itself to give you a negative, it gives you what you're used to seeing as not a real answer. What we're going to talk about today is how we can actually work with these problems. So you would say no real solutions for this. And I can show you that graphically as well. If we use our graph process where I hit y equals, and I just type in the original equation, 2x squared plus 10, and then negative 18, and I graph it. I have to change my window here. That's not a good window. We'll do the standard window first. Nope, still not seeing anything, so I'm going to zoom out for this one. Let's make this about negative 20 and see if that changes. So there's the negative 14. And I'm not seeing my quadratic. Let me zoom out again so I can see my quadratic. Let's make this a little bit bigger as well. We'll make this 50. All right, there's the quadratic, 2x squared plus 10, and then there's the other equation. So notice when this happens, they're not intersecting. Before, when they were intersecting, we were able to get solutions. But now, since they're not intersecting, we're not able to get solutions. And that's why there's no real solutions. But what we're going to talk about is that this creates a special case. And there's a new type of number that we're going to talk about that you probably haven't seen before in mathematics. And this is what you're learning in Algebra 2. So let me get rid of my calculator. So this brings up the conversation of something called complex numbers. And they really arise when you're working with quadratics and square rooting a negative number. So a complex number is a number in the form a plus bi where I equals the square root of negative 1. Another name for a complex number is called imaginary numbers. So they're also called imaginary numbers, which is where the I comes from. So when we're solving our problems like the example we just did, when you get to here, you can actually come up with an answer using complex number notation. So we're going to take a look at some examples of how we rewrite these with complex numbers. So if I ask you what was the square root of negative 81, generally what you would do is you would put it into your calculator and your calculator would tell you no real solutions. It would give you that non-real answers part. But now that we know how to work with, now that we know that there are these things called complex numbers, we can actually simplify this and use the complex number notation. So when there's a negative underneath the square root, you're not going to have to do this for every problem. I'm just going to show you how this works. I can rewrite this as the square root of 81 times the square root of negative 1. So I'm just breaking this up into factors. The number 81 times negative 1 gives me negative 81. So when I do this, now I can actually square root this piece. The square root of 81 becomes 9. And I just said that when you see the square root of negative 1, we use a letter to represent this. The letter represents the square root of negative 1 is I. And this is what we use for complex notation. So we can square root this to become 9i. So really, we're square rooting the numbers like we normally do. If there's a negative underneath it, we're including the letter I to go with it. So another example, if I said the square root of negative 16, I can break it down again into the square root of 4 times the square root of negative I. So it's that's the square root of 16. Make that correction on there. Let me get my whiteout. So that's the square root of 16 times the square root of -1. So the square root of 16 is 4, and then I can rewrite that as 4i. Try another example. Square root of -36. And this time I'm not going to rewrite with the steps. I'm just going to square root it like I know, and then because I see the negative underneath it, I know the square root of 36 is 6, and then because of the negative, it's I, so it turns into 6i. For number 4, we're going to square root, and I'm going to put a negative in front, just so you can see how this works. So now I've got two negatives. So really the only thing that changes here is I'm still converting this like I did these problems. So the square root of -9 is 3i. But now because there's a negative in front, I also have to include the negative in front. The last example I'll show you is when you have the square root of a number that we can't square root. So let's say like I gave the square root of 20, -20. This number isn't a perfect square root. So to simplify this one, we just write this as the square root of 20, and you put the I in front because of the square root symbol. And this way the notation doesn't get messy, because if you try to write the I after, it would get confusing and people might think the I goes underneath the square root. So all we're really doing is taking the negative out and changing that into an I. And that's an imaginary number. And you can continue to working with your problems the way that we've been solving them. So for number 2 in our example that we did on the other page, we could be able to solve that problem. So I'm going to rewrite that equation. This will be our last example here, number 6. If we got to here, like we did in our problem, x squared equals -14, we now can solve this. And you would square root both sides. And the answer this time, instead of non-real solution, we would say there is a solution. It isn't real, it's an imaginary solution, but we can actually write it. So it's either x equals I, the square root of 14, or x equals -I, square root 14. And that's imaginary numbers. That's our introduction to what imaginary numbers are. So try those practice problems that are listed on the website and see if you can simplify some of these problems with imaginary numbers.